This is the key to topic 11, part B, and in this problem you want to solve each of these systems by using substitution. So you must use substitution, you can't use any other method. And then it does say write the solution as an ordered pair. So it's number one. So number one, we have 3x minus 4y equal 10, and then y equal x minus 3. So the easiest way to deal with substitution is this. So the first thing you want to do is look for an equation. For one of these equations, choose one of these equations and get one of the variables by itself. So notice that in number one, the variable y is already by itself. So go ahead and use that one. So basically what you're going to do is in number one, since this equation y is already by itself, you're going to take, I'm going to go ahead and rewrite it over. You're going to take this expression here and you're going to substitute it into y into the other equation. So that's the idea of that substitution. But the first thing you have to do is to get one of the variables by itself. So number one, it was easy because that one's already by itself. And so when you take this expression and substitute into y, because that's what y equals, we get this now. So we get 3x minus 4 times y. Now put that in parentheses because all of this that I have circled will be multiplied by negative 4. So x minus 3 equal 10. And so now let's go ahead and distribute. I get 3x minus 4x. Negative 4 times a negative 3 is a positive 12 equal 10. Combining like terms, 3x minus 4x is a negative x, plus 12 equal 10. Subtract 12 from both sides. I get a negative x equals a negative 2, but remember you got to get x by itself, so this you get divide both sides by negative 1. And so the negative 1's divide out, so 1 times x is x equal a positive 2. So that's the x coordinate. Now all you do is this. You see right here where that y was already by itself? You want to find y now. So to find y, we substitute x equal 2 into one of these equations. Does not matter, but let's just go ahead and use this one right here since y is already by itself. Into y equal x minus 3, and we get this. We get y equal 2 minus 3, because that's what x is, right? 2 minus 3, and so I get negative 1. So the solution as an ordered pair, remember ordered pair means alphabetical order here, so it'll be x, y. So we get x is 2, y is negative 1. All right, and you can check. You don't have to check, but if you check, always go back to the original. So if you go back to the original, so what we found was that this ordered pair is the only solution to the system, meaning that this ordered pair satisfied those two equations at the same time. So that's the only point that these two have in common. So let's check. So let's check the first equation and see if it works. All right, you don't have to check, do not have to check, but let's go ahead and do that. So this is your x, this is your y. So I get 3 times 2 minus 4 times negative 1, and I want to see if that's going to equal 10. Well, 3 times 2 is 6. A negative 4 times a negative 1 is a positive 4, and notice it does equal 10. Now let's do the other one. So the other one was y equal x minus 3. So here's your y, negative 1. So negative 1, I want to see if that's going to equal to x, which is 2 minus 3. Well, 2 minus 3 is a negative 1, and they are equal. All right, so that's your solution, and that's your work. That's the work you have to show. So that's number 1. Now we do number 2. Here's number 2. So again, number 2, we have this. We have x minus 5y equal 32, and then negative 5x minus 6y equal 57. So in do number 2, remember the first thing you have to do is to take one of those equations and get one of the variables by itself. I want you to notice something. Do not choose the second one, because if you choose the second one and get x by itself, you're going to have to divide both sides by negative 5, which introduces fractions. The same thing here. You're going to get fractions if you solve for y, because you have to divide both sides by negative 6. 57 divided by negative 6, negative 5 divided by negative 6. You're going to have fractions involved. Don't deal with that. Go to the first equation, and I want you to notice whenever the coefficient of x or the coefficient of y is 1, that's the one you want to solve for. So we're going to pick this equation here. So we're going to pick this equation, and we're going to solve for y. So I'm going to add 5, solve for x, excuse me. We're going to add 5y to both sides. So I get x equal 5y plus 32. All right, so now that kind of looks, this right here, looks like this now. So I'm going to circle this right here, and I'm going to go to the other equation. Remember, this came from here, so this is going to be my other equation. So wherever you see the variable x, I'm going to substitute what I have circled. So here's what we get. We get negative 5 times, I'm going to substitute into x this now, 5y plus 32, minus 6y equal 57. All right, and so let's go ahead and use the distributive property. So negative 5 times 5y is a negative 25y. A negative 5 times 32 is going to be a negative 160 minus 6y equal 57. Combining like terms, a negative 25y and a negative 6y is going to be a negative 31y minus 160 equal 57. Adding 160 to both sides and combining like terms, this is 0. I get negative 31y equal, and then 57 plus 160 will give you 217. Dividing both sides by negative 31, I get y to equal, using a calculator, you get this to be a negative 7. So you found the y coordinate of your solution. So y is negative 7. So far my solution, remember ordered pair, you got to rise in ordered pair. Make sure you put negative 7 in the right place. So that goes here, negative 7. Now I got to find x. So to find x, you're going to take negative 7, and let's go ahead and use our step 1 right here, because we're trying to find x. So assuming I did this correctly, I did the algebra correctly, let's go ahead and use what we have here. So now we're going to substitute y equal negative 7 into x equal 5y plus 32. And so I get 5 times negative 7 plus 32. So 5 times negative 7 is a negative 35 plus 32. And so negative 35 plus 32 is a negative 3. So there's your x. So that goes here. All right. Now, always check. You have time to check. So just check. So go back to your original. So let's check. Because I could have made a mistake somewhere around here. So remember, I went back and I substituted negative 7 into this equation right here. Well, remember, I got that equation by using algebra. So I could have made a mistake. So now, even though this is correct here, maybe, you are using, if this is incorrect, using an incorrect equation to find x. It's always a good idea to check. So if you're saying that's the solution, check it. You can check this mentally. All you do is go back to your original. You got to use your original, though. You got to look at both of those equations. So our first one is x minus 5y equal 32. Our second one is negative 5x minus 6y equal 57. So let's substitute. So here's your x, here's your y. So x is negative 3 minus 5 times y, which is negative 7, and I want to see if that's going to equal 32. So negative 3, this right here is negative 5 times a negative 7 is a positive 35, and it does equal 32. So that's correct. Over here, negative 5 times x, which is negative 3, minus 6 times y, which is negative 7. I want to see if that's going to equal 57. Negative 5 times negative 3 is a 15, positive 15. Negative 6 times negative 7 is a positive 42. And when you add them up, you do get 57. All right, so that is the solution to number 2. So that is the key to this worksheet, topic 11, part B.